For today's assignment, you have a few ways that you can fill it in. You can print this out and write directly on it and write in the boxes and on the lines. If you don't have a printer, these boxes and lines are fillable, so you can fill them in with numbers and words. Just make sure that if you're writing a lot of stuff on the lines, that you delete some of the line spacing so that the problem doesn't get so large that it runs onto a second line. You could also just handwrite this on a sheet of paper, but I highly encourage you to write out all of the steps, to write out all the labels, to write out all the numbers, to ensure that you're learning what you're doing and that you're doing the right thing. The goal of today's lesson is to derive your own conversion factor for dimensional analysis. In the first example, the question is asking, what is the mass of 560 atoms of magnesium? The first part of dimensional analysis is filling in the given information. So I'm going to put that in this box here. The given information is the 560 atoms of magnesium. So I'm going to put that into the box. The second part is deriving the conversion factor, which we will put here. The question is asking for mass. So we know that in the end, we need grams. Therefore, we need something to fill in the intermediate that will cancel out our atoms and leave us with grams. Recall the AM 6000 definition of elements in that one atomic mass of the element in grams is equal to 6,000 atoms. So if we want to cancel out atoms of magnesium and be left with grams, we need to derive that number from the periodic table. So I have put the magnesium block here, and from here we need the atomic mass. The atomic mass on our periodic table is going to be this number, which we're going to round to a whole number, so 24 grams. And so what that's saying is that there are 24 grams, that's the atomic mass of the element here, per 6,000 atoms. So I'm going to put my 24 grams of magnesium on the top line. On the bottom I put 6,000 atoms of magnesium. My atoms of magnesium will cancel out because what's on top will cancel on what's on bottom. And I'll be left with grams of magnesium here. So now it's a calculation where I do 560 times 24 divided by 6,000. And you should end up with 2.24 grams of magnesium. So in this problem, I derived the conversion factor from the mass on the periodic table. Example number 2 is asking what mass of sodium bromide is contained in 30 milliliters of a 1 molar solution of sodium bromide. So you'll notice right away that there are two numbers in the problem, 30 milliliters and 1 molar. The first thing that you'll need to do is decide which of these numbers is the given number, as in the number that you start with, and which number is a conversion factor. The given number is usually one that is altered or changed by the person doing an experiment, or it's how much you measure. So if you had a 1 molar solution in a stock bottle and you took out 30 milliliters, the 30 milliliters is the number that you are changing. It's the factor that you have control over. Whereas if this is a 1 molar solution, that is just a fact. It just is a 1 molar solution, and we're not going to change that. And there really is no measurement here. And so therefore, the 30 milliliters, which we have put in red, is the given, and the 1 molar is a conversion factor. And we did the same color coding in the rest of the worksheet. So first things first is you put the given in the box. 30 milliliters of sodium bromide. And then we need two conversion factors as shown by these lines. The reason we need two conversion factors is because the question is asking you to convert from volume to mass. There is no direct conversion from volume to mass unless you use density, but that would be of a substance that is not dissolved in water. So because it's dissolved in water, we have a concentration here. From the concentration, we can use our AM 6000 definition in that there are 6 molecules per 1 milliliter of solution. And so in going to our 6 molecules, we know the molecular weight of sodium bromide, so we can directly go from molecules to mass. So that is our process here. We're going from volume to molecules to mass. So now we need to fill in our conversion factors. In order for dimensional analysis to work, the units must cancel out, and canceling happens when something's on the top and on the bottom. So on the bottom of this first conversion factor, we know there must be milliliters of sodium bromide. And because we're using the AM6000 concept, we'll put molecules on top. And then we fill in the numbers, 6 molecules per 1 milliliter. The last conversion factor takes us from molecules to mass. And in molecules to mass, we again are going to use the AM6000 concept, where 1 molecular weight per 6,000 molecules. So that means we need to calculate the molecular weight of sodium bromide. And we do that by adding the two together. Sodium has a mass of 23 grams, and bromine has a mass of 80 grams. And we add those together because it's 1 sodium and 1 bromine for a total mass of 103 grams. So based on our AM6000 concept, there are 103 grams of sodium bromide per 6,000 molecules of sodium bromide. So now we can check to make sure we put all of our conversion factors in correctly by canceling. Milliliters sodium bromide cancels with milliliters, molecules cancels with molecules, and we're left with grams of sodium bromide, which is what the question's asking for, mass. So that should be the last one that we have. It should be the leftover one. Now we can do a little bit of math. Because we're multiplying and dividing, the order doesn't matter. However, in order to stay organized and make sure you hit every number, I like to snake my way through. So 30 times 6 divided by 1 times 103 divided by 6,000. You could multiply all the numbers on the top and divide by all the numbers on the bottom, but when the problems get really long, it's easy to forget numbers. So I, as I said, like to snake my way through and make sure I hit every number on the way. So when we do this calculation, we end up with 3.1 grams sodium bromide. Example number 3 is asking you to calculate the mass of sodium carbonate that's needed to produce 12.5 grams of silver carbonate. In order to solve this problem, you'll need to use a balanced chemical equation. This chemical equation is a recipe. This reaction is saying that if we take aqueous sodium carbonate, which is colorless, so there's nothing in the test tube, plus silver nitrate, which is also a colorless solution, so it looks like there's nothing in the test tube, just water, and we mix those together, put these two together into a beaker, we will end up with a solution that has this solid precipitate at the bottom, a solid that you can collect in a filter. That means you can take the silver out of solution and it becomes something that you can use. Problems like these are really important when you're doing labs because it can help you use accurate amounts of reactants to produce a desired amount of product. So our 12.5, that's our product. We want a certain amount of it, and we don't want to just throw a bunch of stuff into a test tube. We want to do this scientifically and not waste materials. So we can use our recipe here to calculate what mass of sodium carbonate we need. In order to do that, we'll use our molecular weights. The molecular weight is a representation of the total weight of the molecule. So in order to calculate that, we will add together 2 sodium atoms, 1 carbon, and 3 oxygen. And if we add those all together, you get 106. That was done for each of the molecules in the reaction. And wherever there's a coefficient, that total weight must be multiplied by the coefficient. So AgNO3 gets a multiplier of 2 because we've got a coefficient of 2. And Sodium nitrate also has a coefficient of 2, so you multiply that by 2. Now with these molecular weights, we can derive a conversion factor. Because this is a weight recipe, 106 grams of sodium carbonate are needed to make 206 grams of silver carbonate. That's a conversion factor. So as always, we start with our given into the box, and our given is the number. Remember, this is something we've decided upon. So we said, I want 12.5 grams of this. And then we need to fill in the conversion factor. The question is asking for mass of sodium carbonate, so that has to be what we end up with, grams of sodium carbonate. This means whatever is in our conversion factor, the grams of silver carbonate must cancel out, and we must be left with grams of sodium carbonate. And so now we use our molecular masses as our conversion factor. 106, 276. And then we do the math. 12.5 times 106 divided by 276. And that will get us 4.80 grams of sodium carbonate. So in order for us to have this precipitate amount have a mass of 12.5 grams, we need in here 4.8 grams. And if we really wanted to make this an accurate reaction, we would also calculate how much silver nitrate we would need to produce 12.5. It's not going to be 4.8, it'll be something different because our recipe is different up here. All right, you should have enough information to complete the rest of this worksheet.